So this is day 2 of section 5.5, and yesterday all we did was review factoring methods. We didn't even actually get to solving polynomial equations. Yesterday you guys just took down some notes. We didn't actually give you a handout. Why not? Because you've already done pulling out the GCF. You've already factored by grouping, right? So we reviewed all that yesterday. We reviewed solving quadratic equations where the a value was 1. We even reviewed quadratic equations where the a value was not 1. That's where we did that shortcut. So we went over all these different factoring methods, and we even learned the difference of two squares formula, where if you have a squared minus b squared, you could rewrite it as a plus b, a minus b. Now we already knew that, but just thinking of square roots, but this is like the actual formula where you could just rewrite it as a squared minus b squared and plug it into this format. Anyway, we also learned the sum and difference of two cubes formula. That was completely new. We will be using that later on. And today, I want us to finally solve these higher degree equations by using the factoring methods that we would use with the quadratic. Please copy down number 1. Don't copy down number 2 because you're going to need a lot more space than what you see here. So just copy down number 1. So if I told you to solve this quartic equation, you can't pull out a GCF and you're stuck. It's hard to factor. You can't do anything because the quartic, if it were a quadratic, what I mean by quadratic, if it looked like this, ax squared plus bx plus c, then you could either factor, split, and solve, or at the very least, you could use a quadratic formula to solve it. But you see, this is not a quadratic equation, it's a quartic equation. So the instructions say solve by rewriting it as a quadratic. So this is an a to the 4th. I would like it to be an a squared. So we're going to attempt to rewrite this as a quadratic equation instead of a quartic equation. So what would belong right in here, if this was originally a to the 4th, what would I need in here for it to go back to an a to the 4th? A squared. Now, if you're thinking 6a squared, the 6 in there would become 36, so it wouldn't take you back here. So this coefficient of 6, this leading coefficient, I'm just going to leave it out here as a leading coefficient, okay?
Oh, you can do that?
You can do that, yeah. I mean, it's all depending on what benefits you on whichever problem you have. So then I have minus 7a squared. Now check this out. You don't need to put these in parentheses, but I'm going to put in parentheses just so you could see it better, what I'm about to do. And of course a plus 1, and it's still equal to 0. Okay, so what I have here, ladies and gentlemen, is now a quadratic equation. It was originally a quartic, now it's a quadratic. You could imagine that it says 6x squared minus 7x plus 1, right? You could imagine that. And if you're having a hard time imagining that, you could go ahead and actually substitute x for a squared, just to make it look nicer, right? So I'm actually going to take an x value and say that my x is going to be a squared, and I'm actually going to plug it in, okay? So when I plug it in, it'll be 6x squared minus 7x plus 1. Does that make sense, what I just did? Now, you can't just magically do that. At the end of it all, once you get your answers, at the end of it all, you're going to have to replace a squared back into the x's, all right? So it's kind of temporarily make it look nicer so we could actually solve it. Now, this is a quadratic trinomial now. It wasn't, now it is. What could I do to solve this thing? I could factor, split, and solve because it is equal to 0. Or I could use the quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a, to be able to solve it. What would you guys like to do? Quadratic? Or factor, split, and solve?
Factor, split, and solve.
Okay. The a value is not 1, though. You guys still want to try it? What would we do if the a value is not 1?
6 times 1.
Yeah, a times c. That's just 6. Step 2, think of the multiples of 6. That's 1 times 6 or 2 times 3. And you think which pair of numbers combines together to give us that middle value 6? Middle value 7.
-1,
I boxed in the wrong one. Yeah, the 6 and 1 gives us 7, but we want it to be a negative 7, so we're going to make it a negative 1 and a negative 6. Is everybody with me so far? Step 3. Step 3 is to plug it into your factored form answer format. Parenthesis, with the AX term. So our A value happens to be 6, and the X value is X. So we're going to go 6X and 6X. And what do we put in these blank spots right here? The -1 and the -6 from step 2. The -1 and the -6. So let's plug that in. -1, -6. That's barely step 3. Step 4 is to magically divide. Remember that? So we need to magically divide. Is there anything you could divide this first binomial by? No. So we're just going to rewrite it. 6x minus 1 in parentheses. And the other one, could we divide it by anything?
6.
By 6. All right, so it's going to be a x minus 1, correct? And now this 6x squared minus 7x plus 1 is now rewritten as a factored form binomial times a binomial. Now it was originally equal to 0, which it's still equal to 0. So let's all put equal 0 right there, which means now we could split them and solve using the zero product property. So this is going to be 6x minus 1 equals 0, and it's going to be x minus 1 equals 0. Again, remember the zero product property. If you have something times something and it equals 0, the first something could be 0 or the second something could be 0. Then you solve both of them. And what answers do we get after adding 1? We'll get 6x equals 1. Final answer will be what? X equals 1 over 6. And the other one? X equals 1. Ladies and gentlemen, if you put that as your answer, it's going to be wrong. Why is that? Because we found the values of x's, not a's, right? How did we end up with x's in the first place? Because I changed a squares to become x's so it'll look nicer. But the fact is, I replaced my a squares with my x's, so I need to go back and re-replace them. I need to change them back from x's to a squares. Both of these x's need to become a squares again to get them back to a's. So I'll have a squared equals 1/6, and I'll have a squared equals 1. And those are actually two quadratic equations that I need to solve. How do you solve a quadratic equation? You apply a square root. Apply a square root. What you do to one side, you must do to the other, right? A equals, you have to put a plus or minus in front of your answer. And I'm going to leave it like that, square root of 1/6. You could change the way that looks, but I'm going to leave it like that just to keep it basic or a little more easy. And the other one, yeah, when you go square root, you get a equals plus or minus 1. So you get two answers here that are irrational. There are some crazy decimals, and you get two answers there, nice numbers, a positive 1 and a negative 1. So just to relate it to previous sections on chapter 5, if I were to have treated this as a quartic trinomial function on Desmos, and if I were to graph it, my leading coefficient's positive, and it's an even exponent, that means that the end behavior would be both in quadrant 1 and quadrant 2. And also, this W-like curve will cross the x-axis how many times? 4 times. 4 times. It's going to cross exactly at positive 1, at negative 1. And if you were to do this on the calculator, the square root of 1/6, it's actually a decimal, right? It's a crazy decimal. But nevertheless, it's a decimal, and you'll have a positive decimal and a negative decimal. So it'll be 4 exact locations on the x-axis. Anyways, that's not necessary. I just wanted to review and connect that with the previous sections. Number 2. You see, that's a quartic equation. So I see two terms. I know it's a binomial, and there's a minus between it. So this makes me think of difference of two squares formula, right? What is difference of two squares formula? We just did it up here, well, yesterday, but it's right, where is it at? It's right here. Difference of two squares. If you have something squared minus something squared, you could plug it right into the parentheses AB, 1's plus, 1's minus. Really simple. So when I see that quartic binomial below, I'm thinking maybe I could change it to a quadratic binomial, or I have a difference of two squares. So down here, the question is, could I change it to a difference of two squares? What would be inside this first one if I wanted to change it to a square? What would be in here in order to get the m to the fourth? M squared, thank you very much. And here, I don't know, I'm hoping I'm able to do something squared will give me 625. And 25 squared gives me 625, right? Of course, if I were doing this on my own, I'd use a calculator, right? So 25 squared will give me a 625. So 25 goes inside of there, right? So what I've done is I've taken this fourth degree binomial to look like a difference of two squares. So this is like identifying my a value and my b value on the difference of two squares. And then you just go straight to your binomial times binomial. One's going to be plus, one's going to be minus. And you put that m squared right there, put the 25 right there, m squared right there, 25 right there. So let me reiterate here. I use the difference of two squares. And you guys wrote this down in your notes yesterday. When you identify something squared times something squared, if you write it like this, you'll be able to identify your a value and your b value, and the a and b just go right here, and the a and b just go right there, and there's a plus sign and a minus sign between them. Does that make sense? So that's what I did down here. I made it look like a binomial squared, something squared minus something squared. So here's my a, here's my b. It's going to be a plus b and a minus b. It's just using the formula, just plugging in your a and your b once you identify a and b. If we're struggling in math, every day is important. It's like a ladder. Every day is a step on a ladder. So yesterday we went over difference of two squares. Look how we did number 2 yesterday. You had something squared minus something squared. I wrote it in parentheses as something squared minus something squared. And I identified my a and my b. And then I simply plugged in the 5x and the 6, plugged in the 5x and the 6. We had a plus and a minus, right? Same thing over here on this next example that we did yesterday, right? We didn't even have something squared and something squared, but I changed it to parentheses squared with the minus sign. I figured out that there was a 7x to the third in here to give me 49x to the sixth. I figured out there was a 3y. Once you identify a and b, you just plug it in, one's a plus, one's a minus. Yes?
Yeah.
Okay, I don't want to beat a dead horse with a stick, but I hope we understand that now, right? So we understand, I hope. So we're still not done. See, whenever you factor in any method, you're supposed to go inside of the parentheses and see if you could continue factoring, right? Now, right here, you cannot. Yes, it's a perfect square, but it's a plus sign, not a minus sign. So this one's going to stay the same. It's going to be m squared plus 25. But this guy over here, you could actually change the m squared minus 25, again with the difference of two squares, one plus, one minus. You could rewrite it. What's it going to be? M with 5, m with minus 5, right? So we have these three binomials being multiplied together. I've changed the quartic binomial to become a quadratic binomial times two other linear binomials. It is all equal to 0. The whole purpose of factoring is to get the multiplication, so you could use zero product property to split and solve. So you're going to have m squared plus 25, that could equal 0. M plus 5, that could equal 0. And m minus 5, that could also equal 0. So we're going to solve each of these. I'm running out of space here, but minus 25 on both, you will have m squared equals negative 25. And we get rid of a square by square rooting. And we do to one side, you must do to the other. But remember, whenever you apply a square root, you must put a plus or minus in front of your answer. The square root of negative 25 will be 5 with an I. The negative sign will come out as an I, and the square root of 25 is 5. I times 5 is 5i. So this is actually two answers to the original Quartic equation. And we're going to get two more answers by continuing to solve. You're going to get m equals negative 5, and you're also going to get m equals positive 5, if you show your work there. So these are the four answers to this Quartic equation. Let's jump to the worksheet, guys. On this worksheet, the first part is simply practicing your factoring methods. What's the first type of factoring method you should try? Guys, the first type of factoring you should always try is pulling out the GCF. So let's look at number 2 and let's pull out that GCF. What could I pull out? What is a GCF? 3. Is there any letters that I could pull out as well? And? T. Right? There's one S, 3 S's, 2 S's. You could pull out one of those S's from all of them. There's 2 T's, 1 T, 2 T's. You could pull out 1 T from all of them. What's going to be left? If you say 3ST times what takes you back to here, what's missing?
T.
The T. Whoops. Whatever. That's a T right there. And then when I go 3ST times what will take me back to here?
3S.
Minus 3S squared. And the last one, 3ST times what takes you back to that last one? 2S and a T. Okay, cool. And there's nothing else to do in the parentheses. I'm done. If you check the back of the worksheet, that's what they do. They just pull out the GCF. So I did number 2. I want you guys to do number 4, which is exactly done the same way. But you're going to do that on your own, okay? The answers are in the back. Let's jump to number 6. The next even one. Is there a GCF we could pull out of all those? No. So what method are you going to use? What different method? There's 4 terms.
Okay, the difference of squares?
There's 4 terms. What are we going to do?
Grouping.
Grouping. So let's separate first group from the second group. I mean, we're going to try to group at least. Let's see what happens. Could I pull out a GCF from the first group?
X.
Yes, X. What's left over on the inside?
X. Minus Y.
There you go. And what could I pull out of the second group? 2. Bless you. What's left over?
X minus Y.
And luckily, we have the same exact binomial in the first group and the second group. So we're going to factor out that common binomial. I want to write that common binomial x minus y out here. I want to exaggerate some parentheses, and the x comes down and the plus 2 comes down. Final factored form is x minus y with the correct size parentheses, x plus 2. That's just a review of chapter 3, factoring by grouping. I think you guys will be able to handle number 8 the same way. Let's jump to number 10. Do we even need to see number 10? That's really factoring where your A value is not 1. So you would go step 1, A times C. Step 2, make a list. Do you guys want to see that, or you guys got it? You got it. All right, cool. Let's move on. Let's go to number 14. But even before 14, even though we're not doing the odd ones, I want to do 13 to help you to understand this next section better. The next section, it doesn't say factor. It doesn't even say solve. This next section is just having you practice rewriting a 4th degree polynomial down to a quadratic, or rewriting an 8th degree polynomial down to a quadratic, or rewriting a 6th degree polynomial down to a quadratic, right? And that's just a skill that we need to be able to do this next section. So let me tell you this right now. In order to change this to a quadratic, whatever degree you have, this next term better be half of that power. Is 2 half of 4? Yes. So watch the way it'll work. If you try to change that power of 4 to a power of 2, what's going to be inside the parentheses? Of course, the leading coefficient stays outside. A b squared. And notice that that's the same exact value that you have right here. Now, you don't even need parentheses right there, but I'm doing it right there so you could see, like if this were a x squared and this were a x. And this minus 11 would be your C value.
Oh, you don't have to.
Yeah, they're not telling you to solve. They're not telling you to factor. All they're doing is asking you, can you change it from a higher degree polynomial to a quadratic trinomial? And I'm telling you right now, in order for this to happen, your degree has to be twice as big as this next power. If it's not, it's not going to work. So why do we want to learn this skill? Let's start with that. Why do we want to learn the skill? Because if this were an equal 0, then this would be equal to 0. And you could pretend that this is an x, and you would say ax squared plus bx plus c, and you could use a quadratic formula to get your two answers with regards to x. But then you'd have to replace your x's with b squares. That way you could square root the b's and square root your answers to get your final answers for b instead of x. Dang. It's a lot of stuff.
So we don't solve for these?
Nah, we're not solving. We're just changing them from whatever they are to a quadratic if possible. So again, you need, I'm sorry, before I move on, you need your degree to be twice as big as this next one. Could you change number 14? No. Why not? If this were a 4, then yeah, I'd be able to do it, but it's a 2. So watch this. Even if I tried, if I say, okay, what squared, what belongs in there? X to the 4th. So you would have negative 5x to the 4th squared plus 1 x to the 2nd. Now you see how these are no longer the same? So it would not be like if you had 5x squared plus 1x. It's like 5x squared plus 1y. It's like something totally different. X to the 4th and x squared. It doesn't work.
You're saying like the inside have to be the same?
Those inside values have to be the same.
Oh, okay.
Okay, so that's why right here it's just not possible. Not possible. So they're asking, are you able to, check it out, it says, are you able to write the expression in quadratic form? Is it possible? No, this one's not possible.
What if you flipped it?
How about number 15? Could we change that one to a quadratic? Yeah, we could. Why? Because the degree is 6 and this next one's 3. It's half of it. So check it out. If I were, let's just leave that leading coefficient 28 out there. Let's change it to a square. What's going to be on the inside? D to the 3rd. And then we have plus, put the 25 on the outside. And what's going to be in there? D to the 3rd. Now, it's a quadratic, but it's not a trinomial. If you want the c value, just put a plus 0 if you want.
But it's not quadratic because I have e to the 3rd.
It's a quadratic because it has a square.
But the highest degree is
So I guess let me explain what I'm trying to do here. We're practicing just one little step, one skill. We're practicing that one skill. That way, when you get to a problem like this, I guess in this one it's kind of irrelevant because you could actually pull out a GCF of d to the 3rd. But my point is, right here you would be able to substitute, change that d to the 3rd to an x, change this to an x, and it would look like a quadratic trinomial equation, 28x squared plus 25x plus 0. And then you could solve that with the quadratic formula or with any other factoring method. And once you get your answers, x equals something and x equals something, you take the x's and replace them back with d to the 3's. That way you could take the 3rd root and continue working on your answers.
But is that by itself a quadratic equation?
We converted the 6th degree equation to look like a quadratic equation.
But not the d3 to the 3rd.
Again, check this out, man. The real reason we're doing this is like, let me show you right here, 23, right? 23. Let's jump to 23. That's going to be part of your homework anyway. This is not a quadratic, so you can't do anything. You can't factor it. But if you make it look like a quadratic, something squared, minus 50 times that something plus 49, what would be in here to get the x to the 4th? X squared and x squared, right? So now this does look like a quadratic. It's like if it were, pretend it's a big giant x. X squared minus 50x plus 49. So if you wanted to, you could say, you know what, I'm going to replace my x squares with an a. Now, you know what, this substitution, a lot of people get messed up with it. You don't need to do the substitution. You could just leave it like that. Imagine this. If you had something squared minus 50 times that same something plus 49, imagine if those were giant x's, wouldn't you just do parentheses, and you would normally put x, but instead of x's, we have x squares. So you could just put the x square right there and the x square right there. Then after that, you're just going to think, what times what is 49? Positive 49, that if you combine together is negative 50. So what times what is positive 49 that if you add together is negative 50? Negative 49 times negative 1, right? Negative 49 times negative 1 is positive 49. If you combine them together, it gives you negative 50. So see, the substitution part's not absolutely necessary. You could just understand that if this were an x and that were an x, you would just write your x here and your x there. And then think what times what is c that if you combine together is b and put them right here. So we have factored this. How? By changing the quartic to look like a quadratic. So that's a skill that we're practicing on the previous section. And now that it looks like a quadratic, we were able to factor it. It's still equal to 0. So at this point, you could either continue factoring with the difference of two squares, factoring with the difference of two squares, having 4 terms, and then splitting them all up and solving each of those easy equations. Or you could stop right here and split them right here and say x squared minus 49 equals 0, x squared plus 1 equals 0, and solve both of those equations. It's totally up to you. Do you guys want to split right now? Or do you want to factor and then split at the end? Split right now? Okay, if we split right now, it'll be x squared minus 49 equals 0. It'll be x squared minus 1 equals 0. So you're going to go plus 49. You're going to have x squared equals 49.
Plus or minus? Oh, no, minus. Plus or minus 7, right?
Yeah, you're going to square root x equals plus or minus 7. That's actually 2 answers. Over here, same deal, plus 1, plus 1. You're going to have x squared equals 1, square root x equals plus or minus 1. That's 4 answers. This quartic equation that has a leading coefficient of 1 is going to have n behaviors in quadrant 1 and quadrant 4. It's actually going to cross the x-axis at 4 locations: positive 7, negative 1, positive 1, and positive 1, and also positive 7. Getting jumbled up here. Okay, let's go back to other questions on this last section. Okay, how about number 20 right above? You're not always going to have to change them to quadratics. I mean, sometimes it happens naturally, right? What's the first type of factoring you should always try? GCF. What could I pull out of this thing?
K to the third.
And what's left over?
K to the second. K to
Isn't that nice? On the inside, we end up with a quadratic trinomial with the a value of 1, which means we could just try to do this. What times what is negative 32? That if you add together is positive 4. If you forget, you could do negative 1 times 32, negative 2 times 16, negative 3 doesn't work, negative 4 times 8, negative 5, negative 6. That's it. Which pair of numbers combines together?
Negative 4 and 8.
Negative 4 and 8. So if I combine negative 4 and 8, it will give me the middle value, positive 4. So I have a negative 4 right here, positive 8 right there. We factored it, bring down the k to the third equals 0. And now you have zero product property that you could apply. If you have something times something times something equals 0, each of those somethings could equal 0.
K equals 0, K equals 4, K equals.
So we have, right here you would have to apply a cube root and a cube root. That would be k equals 0. Plus or minus 0 still ends up being 0. And as a matter of fact, that third root is technically going to represent 3 zeros, even though it's only one answer. In the future, we're going to say that this 0 has a multiplicity of 3 in the future. I'm just throwing it out there right now.
What axis is that?
The 0 will, let's get the rest of the answers, and then we'll talk about what it actually looks like on the graph. K equals 4, and k equals negative 8. So I know that this 5th degree polynomial equation, the a value is positive, so it has one n behavior in quadrant 3, one n behavior in quadrant 1, right? And it's going to be some squiggly lines. It will cross the x-axis at 0, 4, and negative 8. It is possible for it to cross a maximum of 5 times, but this 0, because it had the power of 3 on it, it technically represents three zeros. There's a duplicity of 3. I'm just throwing that vocab term out there. We're going to learn about that next week. Okay, how about this last one, the word problem? What? We're doing a word problem? Yes, we could read. Physics. A proton in a magnetic field follows a path on a coordinate grid modeled by the function f of x equals x to the 4th minus 2x squared minus 15. What are the x coordinates of the points on the grid where the proton crosses the x-axis? So what are they really asking for? They're asking for the location of the x-axis, which means they're asking for the x-intercepts, which means that they're asking for the solutions. How do you find the x-intercept anyway? You set y equal to 0. So what you would do is set this thing, x to the 4th minus 2x squared minus 15, set that equal to 0, and of course solve it. That'll give you your x-intercepts, your answers, your roots, your real zeros. Anyhow, that's a quartic trinomial. It would be nicer if it was a quadratic trinomial. What must be in that parenthesis in order for it to end up as an x to the fourth? X squared. Now we do have the minus 2 times x squared, and that's great because we have an x squared in there and x squared in there. You have your minus 15 as your c value, and you have the equals 0. So by changing your quartic to a quadratic, just making it look that way, you could use now your quadratic formula where your a value is 1, your b value is negative 2, your c value is negative 15, or you could try to factor, split, and solve. And thinking, normally we would put an x right here and an x right there. That's when you would have x squared and x's. So if you had an x here and an x there, you would put your x's here. Right here, you're going to put x squares right there. So I'm avoiding substitution. Of course, I could have substituted and then resubstituted back in at the very end, but I'm just going to leave those as x squares instead of x's and just move on with my factoring. What times what is negative 15 that if I combine together is negative 2? Positive 3 and negative 5. So we have factored, and you got to look at the inside and see if you could continue factoring, and you cannot. If this would have been a 9, you could do the difference of 2 squares, but it's not a 9, it's a 5. So that's all you could do. Let's split them and solve now. So when we split them, we're going to have x squared plus 3 equals 0, and x squared minus 5 equals 0. So you're going to have minus 3, x squared equals negative 3. You apply a square root, you're going to have x equals plus or minus. You end up with an imaginary, and it's still the square root of 3, which is actually a decimal number if you figure that out on the calculator. But either way, that's still imaginary. On the other one, plus 5, you're going to end up with x squared equals 5. And when you apply a square root, you will have x equals plus or minus the square root of 5. That is actually a number, a real number. It's a nasty decimal, but it's a real number. It's a real location on the x-axis. So the question here was, where does a proton cross the x-axis? What locations would it cross it at? What do you guys say? How many times will it cross? Twice, only twice. Where exactly? At the coordinate 0, positive square root of 5, and also 0, no, I'm sorry. I said that backwards. Negative, I'm losing it. Square root of 5, 0, and negative square root of 5, 0. Those are the x-intercepts. These are imaginary, which means that there is no real x-intercept on those. The only real locations are at positive square root of 5 and negative square root of 5, which is really negative 2 point something and positive 2 point something. So I did most of the homework here, guys. I need you to go back and do the rest of these at home. Check your answers on the back. Please don't fall behind. We're picking up with the same stuff on Monday.